Nearly 4 billion miles apart in composition, orbit, and history, two of the strangest worlds in our solar system just revealed something they apparently have in common. Pluto, a tiny, frozen dwarf planet at the very edge of our solar system, and Titan, Saturn's massive E, hazy moon, have both produced the exact same unexplained signal and data captured by the James Webb Space Telescope. Scientists have compared it against every known molecule ever cataloged in planetary science. Nothing matches. This is the story of the mystery molecule hiding on two completely different worlds, and why researchers still can't say exactly what it is. If discoveries like this fascinate you, hit subscribe now, because we break down the universe's most puzzling unsolved mysteries every single week. Let's start with why researchers were even comparing Pluto and Titan in the first place, because on the surface, these two worlds seem to have very little in common. Titan, Saturn's largest moon, is shrouded in an extraordinarily thick nitrogen and methane atmosphere, with surface pressure roughly 1.5 times greater than Earth's, about 50 times denser than Pluto's own thin, wispy atmosphere. Pluto, by comparison, is a small, distant dwarf planet sitting billions of miles farther from the Sun, with a surface pressure so low it barely qualifies as an atmosphere at all by Earth standards. Despite these dramatic differences, both worlds share one key similarity that made this comparison scientifically worthwhile in the first place: atmospheres dominated by nitrogen and methane, the exact chemical ingredients capable of producing complex, occasionally unpredictable photochemistry when exposed to sunlight and radiation over billions of years. A research team specifically decided to examine James Webb Space Telescope data, covering infrared wavelengths that had received relatively little scientific attention in previous studies of either world. That decision to look somewhere researchers hadn't focused on before turned out to be exactly the right call. Here's precisely what they found. Like this video right now, if you want to understand exactly why an identical signal appearing on two such different worlds has scientists genuinely stumped. While comparing the infrared spectra of Pluto and Titan, researchers identified a distinct, unmistakable absorption line centered at a wavelength of approximately 5.11 micrometers, present in the data captured from both worlds. An absorption line like this represents a specific wavelength of light that's being blocked or absorbed by what our material is present, essentially a chemical fingerprint unique to a specific molecule's atomic structure. Researchers immediately cross-referenced this specific signal against the extensive, well-documented catalog of known molecular absorption features recorded throughout planetary science. According to the study's own published conclusion, they did not find any previously documented band matching this specific wavelength anywhere in existing scientific literature covering our solar system, or notably in observations of exoplanets beyond it either. That's a genuinely remarkable statement for planetary scientists to make. Decades of accumulated spectroscopic data covering nearly every planet, moon, and atmosphere studied in detail throughout our solar system, and this specific signal simply doesn't match anything previously cataloged. Don't forget to subscribe before we get into exactly how researchers confirmed this signal was genuinely real, rather than simply an instrument error or observational artifact, because the verification process itself is worth understanding. To confirm this mysterious signal was actually coming from Titan's surface, rather than from somewhere within its notoriously thick atmosphere, researchers used a clever comparative technique. They specifically compared the spectrum captured from the center of Titan's visible disk against spectra captured from its outer edges. If the absorption signal originated from gas within Titan's atmosphere, it should appear stronger at the edges, where light passes through a greater overall thickness of atmospheric gas on its way to the telescope. Instead, researchers observed the exact opposite pattern, with the signal actually appearing weaker at Titan's edges. That specific result strongly indicates the absorption originates directly from Titan's solid surface, rather than from any atmospheric gas, ruling out one significant potential source of confusion right from the start. Once researchers confirmed this signature as a genuine surface feature on Titan, they specifically checked archived Webb observations of Pluto, captured back in May of 2023, to see whether anything similar might be present there as well. To their genuine surprise, the exact same 5.11 micrometer absorption feature appeared in Pluto's data too, though with some notably different characteristics. On Pluto specifically, researchers found this absorption signal spans roughly 3 times the wavelength range it covers on Titan, while its overall depth or intensity remains fairly similar between the two worlds, both showing absorption strength in the range of 4 to 5%. Here's why those specific differences matter scientifically, rather than simply representing confusing technical noise. Make sure you're subscribed because these subtle variations actually provide genuine clues about what might be causing this mysterious signal in the first place. Researchers have proposed several theoretical candidates that could potentially explain this unexplained absorption, while being careful to note that none of these possibilities have been confirmed. One leading hypothesis suggests the signal might be caused by benzene, a ring-shaped hydrocarbon molecule, potentially mixed together with some other currently unidentified molecule. Alternative theories propose the signal might instead be caused by some specific form of acetylene ice or possibly ketone ice, both chemical compounds known to exist in trace amounts within similarly cold, methane-rich environments elsewhere in the solar system. The research team has been explicit, however, that considerably more work remains necessary before any of these specific candidates can be confirmed as the actual definitive explanation for what's producing this signal. There's also a genuinely intriguing detail specific to Titan that adds another layer to this mystery. Researchers noted that this molecule, whatever it ultimately turns out to be, appears unevenly distributed across Titan's surface, with a notably stronger absorption signal detected on the Moon's trailing hemisphere, the side facing opposite to the direction of Titan's orbital motion around Saturn compared to its leading hemisphere. That kind of directional asymmetry often indicates a molecule's formation or accumulation is directly influenced by exposure to specific external factors, potentially including charged particles from Saturn's powerful magnetosphere, which would naturally interact more intensely with one specific hemisphere of an orbiting moon than the other, depending on the geometry of that moon's orbit relative to the planet's magnetic field. Pluto, by contrast, lacks a large host planet capable of producing this same kind of magnetospheric asymmetry, and yet still displays a similar, if not identical, version of the same mysterious signal. That distinction, present on both worlds, despite considerably different physical environments and formation histories, is part of what makes this discovery so genuinely puzzling to researchers currently studying it. It's also worth understanding why this specific finding required examining archived data at all, rather than emerging from a single, dedicated new observation. Webb routinely captures enormous amounts of scientific data during each observation, often containing far more information than researchers, analyzing any single, specific research question initially focus on. This particular research team specifically went back through existing, already collected Titan and Pluto data, examining a portion of the available infrared spectrum that previous studies hadn't specifically prioritized, precisely the kind of methodical, patient re-examination of archived observations that has repeatedly proven capable of revealing new discoveries, sometimes years after the original data was actually captured. Findings from this research were posted to the preprint server Archive on June 11, 2026, with the studies specifically slated for publication in the peer-reviewed journal Astronomy and Astrophysics, representing an important, credible scientific venue for this kind of planetary science research. That publication pathway matters, since it means this specific finding will undergo the standard peer review process, with other qualified researchers in the field reviewing the methodology and conclusions before the study's final, formally published version appears in the scientific literature. Looking ahead, researchers studying this specific mystery have indicated that considerably more analysis remains necessary before they can confidently identify exactly what's producing this shared, unexplained signal on two such dramatically different worlds. Additional laboratory experiments, specifically testing how various candidate molecules, including benzene mixtures, acetylene ice, and ketone ice, behave when exposed to the extreme cold and radiation conditions found on both Pluto and Titan, would likely help researchers narrow down which specific compound, or combination of compounds, actually matches the observed absorption signature most closely. For now, this discovery adds a genuinely compelling new mystery to the growing list of surprises Webb has revealed about both of these worlds since beginning full science operations in 2022. Pluto, already confirmed to host an atmospheric haze that functions as a genuine active climate-regulating system unlike anything else in our solar system, and Titan, long recognized as one of the most chemically complex, Earth-like moons ever studied, now share an additional, unexplained chemical signature that neither world was previously known to display, a molecule that has never been identified anywhere else in our solar system or in any exoplanet studied to date. Let's take a closer look at exactly why finding an unidentified molecular signature like this carries such significant scientific value. Specific, predictable wavelengths determined precisely by its unique atomic structure and chemical bonds. Over decades of laboratory research and spacecraft observation, scientists have built an extensive, detailed catalog of these absorption signatures, allowing researchers to identify the presence of specific compounds simply by matching an observed signal against this established reference library. When a genuine, confirmed signal doesn't match anything in that extensive catalog, it typically means one of two things. Either an already known molecule is behaving in some unusual, previously undocumented way under these specific extreme conditions, or researchers have detected evidence of a genuinely new, previously unidentified compound entirely. Both possibilities carry real scientific significance. If this signal turns out to represent a known molecule behaving unusually, that would still provide valuable new insight into how familiar chemistry behaves differently under Titan and Pluto's specific combination of extreme cold, low finding, expanding the basic catalog of known chemical compounds that exist naturally within our solar system's coldest, most distant environments. It's also worth understanding how this specific discovery fits into the broader pattern of surprises Titan and Pluto have each produced individually over the years. Titan has long fascinated researchers precisely because it asks nitrogen and methane. Rich atmosphere, combined with organic surface chemistry, bears certain structural similarities to conditions scientists believe may have existed on early Earth, before life first emerged here billions of years ago. Studying Titan's complex chemistry offers researchers a rare natural laboratory for understanding prebiotic chemistry, the kind of chemical processes If this story gave you a new appreciation for just how much mystery remains hiding within worlds we thought we already understood, make sure you're subscribed, because there are more genuinely unsolved cosmic mysteries coming every week. Hit like, drop a comment letting me know what you think this mysterious molecule might actually be, and I'll see you in the next video.